Good morning, good afternoon, and good evening, my dear kids, my dear students. This is Haritha Kasturi from PACE, Hyderabad. Today, let us go with atomic structure, right? The very important topic of JEE Mains, Advanced, MSET, whichever levels we are talking about. Very important atomic structure. At least two questions from this chapter is mandate I would say, right? Which means two questions is almost 4 plus 4 8 marks is huge enough weightage for this chapter. So focus on this chapter well, and understand it well. Any doubts, please reach out to me. All right, so let us start. Before starting even the textual part of it, I would just like to give you an information regarding the actual person who has given us this theory. We should all be proud of it. Sage Kannada Maharshi. Okay, Kannada Maharshi. Kannada Maharshi has given us the theory of atoms. So generally, father of chemistry is said to be the John Dalton and all, but no, उनका भी father grandfather है हमारे sage Kannada Maharshi. Okay, who has given us the exact atomic model, atomic structure, even before all these so-called advanced studies have been started, right? So, in his memory, with his blessings, let us start our theory of atomic structure. So according to the book, whatever you have here is, the Indian and Greek philosophers around 400 BC, they have given us this theory, and it has been derived from the Greek word atomio. Atomio is uncuttable or non-divisible. So that is what is called as an atom, is given as, further more refined, pronunciations and all, given as the word atom. So the ever first, scientist who has given us this theory is John Dalton. So even before that, we have some of the, models that are being given by Anthony Lavoisier, then who has given us the theory of law of conservation of mass, and Joseph Prost. Joseph Prost, he has proposed law of constant compositions. Lavoisier is law of conservation of mass. So in case you wish to write it, I want you to write it. Please do take out your books, pause it up wherever we are going fast, pause it, then you can write it, then continue. That is how we can go. In case you still have any doubts, please reach out to me. All right. Next, then Joseph Prost. He has given us law of constant compositions. So a few of the theories, we are going to discuss more about these things later. So the very first theory initially was being given by John Dalton. Dalton's atomic model, you're all familiar with in your school syllabus as well. Dalton's atomic structure, or Dalton's atomic model, I would say. What are his postulates? Postulates is what is that he has derived out of his experimentations and all, right? That would be postulates. So the very first postulate, what he has told is matter is made up of small indivisible particles called atoms. Yes, indivisible particles. He named them atoms. Yes, they are smallest particles, but they are not indivisible, because there are some theories which are opposing his theories. Out of them, few of the postulates what he has given were not true, were not being proven true. Okay, and why I'm saying that were not being proven true, because chemistry is a very gray kind of subject, wherein in case there is another person who is coming up with another theory, yes, depending on the experimental proofs and setups, we may go with that as well, because that is how the first John Dalton has come up with his theory, then J.J. Thomson has given us a theory, and then came up with Rutherford's theory, then Niels Bohr's theory. So likewise, we have so many people coming up with more refined theories of structure of an atom. So thereby, we are now discussing Dalton's first, the first ever theory proposed by Dalton's, out of which the first point, first postulates given by him is indivisible particles. Atoms are made up of, matter is made up of indivisible particles called atoms. Partially right, because it is not indivisible. We do have protons, neutrons, and electrons, which are the subatomic particles, which means yes, atom is divisible. Next, number two, atoms can neither be created nor destroyed in a chemical reactions. Can neither be created nor destroyed, which is also yes, but that means that in a chemical reaction, a simple rearrangement of atoms will be done. Atoms are neither created nor destroyed. Fine. Then atom is the smallest particle of an element which takes part in the chemical reaction. Yes. Then atoms of same elements are identical. He has given atoms of same elements are identical, in shape, size, and mass, which this point also is wrong. Why? Because there are some things called as isotopes. Reason why is this a wrong statement? There are something called as isotopes, are the elements with same atomic number, but different mass numbers. Okay, the same atomic numbers, but different mass numbers. This you have done it in your 10th standard, 9th standard as well, right? From your textbook part. This is all I'm just brushing off on these things because atom examples, I would say. Example is hydrogen 1, 1, hydrogen 1, 2, hydrogen 1, 3, right? So, which means this is proton plus neutron here. 1, 2 is proton plus neutron. 1, 3 proton plus neutron. But the upper one, what I'm writing here, some element X with Z on the bottom and A on the top. What does that mean? Z states your atomic number or proton number. This is nothing but proton number or electron number for a neutral atom. Wherein A stands for proton plus neutrons. This is nothing but atomic mass or mass number for proton plus neutrons. Electrons are not considered in the mass because electrons have got a very negligible mass. Almost 1800 times when you divide your proton, then such small minor mass is the electron mass. So therefore, electron mass is not considered. We all know that, right? So hydrogen 1, 1, this is protium, deuterium, and tritium. Okay, these are three isotopes of hydrogen. Another examples of isotopes: carbon C6, 12, and C6, 14. There will be a mass of 14 and there will be a mass of 12 as well for carbon, which indicates that there is a change in the mass number, but it is the same element, carbon. So this is an exceptional case of his postulate. He has given the postulate saying atoms of the same elements are identical, but here they are not identical. So isotopes you are having which are non-identical. Then he has given atoms of different elements has different mass. This also is wrong. Why? Because we have an example wherein argon and your calcium, argon coming at number 18 with a mass of 40, calcium coming up with a 20 atomic number having a mass of 40. Both of them have the same atomic masses, but they are not the same elements, right? These are called as isobars. He could not explain about the existence of isobars and isotopes, right? Both of them could not be given by him reasoning. Then atoms of different elements combine in fixed whole number ratios to form compounds, which is right. Atoms of different elements combine in fixed whole number ratios to form different compounds. which is right, which is definitely right, because the same elements, hydrogen and oxygen, they can be forming H2O, they can be also forming H2O2, right? And how is this formed? Because of their mass ratios. Now, what is the mass ratio of hydrogen is to oxygen? Let us define the mass ratio for hydrogen is to oxygen. Hydrogen, each mass for the hydrogen is 1, and you have two such hydrogens, which is 2. And each oxygen has got a mass of 16, and you have one such oxygen. Now it is a simple whole number ratio, 1 is to 8. If the elements hydrogen and oxygen combine in a mass ratio of 1 is to 8, it is going to get as water. We are going to get water. Whereas now let us see hydrogen of the mass, each mass of the hydrogen is 1. You have two such hydrogens, and each oxygen mass is 16. You have two such, which is 32, which means 1 is to 16. If they combine in the mass ratio of 1 is to 16, then what you're going to get is H2O2, which is your peroxide, hydrogen peroxide, right? So the same elements they are, but when combined in different whole number ratios, they yield us different compounds. So this postulate of his is right, definitely. Yes. Now, what are his drawbacks? We have already discussed. Discovery of isotopes and isobars were not being explained by him, and atom can be split into more fundamental parts. He said that atom is indivisible, which is not true. Atom can be split up into more fundamental particles, electrons, protons, and neutrons. So these are a few examples, drawbacks, which could not be accepted by the next coming up scientists around. So this led to this very drawback of his led to the discovery of electrons, protons, and neutrons. Okay, so these are all being found now. Let us discuss their existence also now. Right. So now moving on with our next concept here. This is your discovery of electron by J.J. Thomson. Okay, J.J. Thomson has given us his theory of discovery of cathode rays. He said discovery of electron by cathode ray discharge tube. Right? So cathode ray discharge tube. Now, what do you mean by cathode ray? Now, we have something called as cathode ray discharge tube. Now, here is your discharge tube. Please excuse me for my drawings. I'm not so good at it. Please open up your textbooks in case you're not good with this. Yes. So, in your textbooks, you can just go through it. This is your cathode ray discharge tube used for the production of cathode. This is your cathode rays. This is cathode, which is your negative terminal of the battery, and anode, which will be your positive terminal connected to the positive side of the battery we are using here. Now, there are a few conditions. There has to be one vacuum pump, which would evacuate all the gases from it initially. Then from the cathode is this negative terminal. As you can see here, there are rays of beams of electrons coming up here. These are called as cathode rays. And the main conditions for it, extremely low pressures, extremely low pressure. And how low it is? 0.0001 mm of Hg is such extreme low pressures, what we are considering them to be the condition. Okay, and voltage is as high as, very high voltages, as high as 10K to 20K volts, 10K to 20K or 15 kilovolts. The voltage what we come across at our homes is 220 volts. 220 volts is the voltage what we come across here in the domestic purposes, wherein this one we are talking about a setup wherein the voltage is as high as 10,000 volts, so huge, and extremely low pressures and extremely high voltages. extreme high voltages, this cathode rays will discharge, will just pass on these cathode rays. These are called as cathode rays. Now, what are these properties of these cathode rays? Now, these properties, the cathode rays have a tendency when they are hit onto a thick metals. Okay, if I place a very thick metal disc or a heavy metal disc, these rays have a property of producing X-rays when hit. These electron rays, beam of rays, when hit over a thick metal, they produce X-rays. X-rays are produced. Okay, this is one characteristic of these cathode rays. And the other one, when you are putting a paddle wheel here, paddle wheel, a wheel kind of thing. Okay, and these rays will show the mechanical effect. What do I mean by mechanical effect? This wheel starts rotating, thereby we understand that there is some mechanical motion, there is some motion. Anything which creates some motion has got some mechanical energy in it. So these cathode rays, although they are negligible, the rays are very negligible, they constitute electrons in them, but due to their high speeds, the momentum of these electrons is high. What do I mean by momentum? Momentum stands for mass times velocity as the mathematical expression. But what is momentum? Momentum defines the motion of an object, motion. So how fast is that moving? What is the kind of motion which is there in it, in that particular substance? That is what is the motion is being defined for the momentum. And these electrons, although they have negligible masses, they come with high speed, high speed, so thereby having high momentum. Momentum stands for mass times velocity, letter with P, right? So therefore there is being shown some mechanical effect, thereby rotating the paddle wheel. That is one point which is shown by it. And if we have some positive terminal over here, if I put a positive terminal, these rays get deflected towards the positive terminal, because in indicating that this is the negative rays. Since they get deflected towards the positive terminal, they indicate that they are the positive rays. And next, when you put a magnet here, there is a bar magnet with north pole and south pole here. These rays will tend to get attracted towards the north pole of the magnet. There is a deflection observed. Deflection in these rays will let us know that these are the charged particles get deviated with the electric field, with a strong electric field or a magnetic field. In case you have a positive terminal, they deflect towards the positive terminal, indicating that they are negative, and they do deflect towards the north of your north pole of your bar magnet, right? So indicating that they are these negative rays, negative beam of rays. So these are, and they do possess the kinetic energy, due to which definitely these rays are showing the motion here. It is able to rotate this paddle wheel because of such huge amount of velocities they are coming up with, huge amount of momentum. This paddle wheel gets rotated, which indicates that they possess the kinetic energy and produce mechanical effects. So these are the things which is given by Mr. J.J. Thomson, and he also has given us the charge by mass ratio. There is something called as charge by mass ratio. Now, what is the charge of an electron? Charge of an electron is 1.6 into 10 to the power minus 19 coulombs with a negative. I'm not showing the negative because I'm just writing the ratio. It's just a comparison. By mass, mass is 9.1 into 10 to the power minus 31 kilograms, right? So now this is the charge by mass ratio, which turns out to be 1.76 into 10 to the power 11 coulombs per kg. Okay, this is the value of your charge by mass ratio. So where m is the mass of the electron and e is the magnitude of the charge here. So the E by m ratio of the electron was found to be the same irrespective of the nature of cathode. Whichever the nature of the cathode rays are producing these beam of electrons here. That is how is indicated by the charge by mass ratio, right? So this is about your discovery of electrons. Now let us move on to the discovery of protons. Discovery of protons here by Mr. Goldstein, right? Discovery of protons. Goldstein experiment. Goldstein experiment, same kind of a discharge tube you will see. Discharge tube with anode here, positive terminal, and you have a perforated cathode. Perforated cathode here. Cathode used here is made up of holes. All these holes are there. This is called as perforated cathode with a negative charge here, perforated cathode. And here again, I'm putting a battery, okay, high volt battery. Yes, because what we have a vacuum pump also. I'm not drawing that vacuum pump. Vacuum pump also will be present to remove the air here. And cathode ray, this is the, discharge tube what I'm using here. Now from the positive terminal, there are rays which come up here with a positive charge on them. Discharge tube, conditions of the discharge tube again has to be number one, extremely low pressures as low as 0.0001 mm of Hg. Whatever pressure we experience is 1 atmospheric pressure, which is 760 mm of Hg. Now imagine the pressure is 0.001 mm of Hg, is so very low pressures, and extremely high voltages around 10 kilo to 15 to 20 kilovolts. Okay, 15 to 20 kilovolts. So high voltages. These experiments are carried on. Now here, what is that, characteristics what we observe? These ray travel in straight lines. Yes, they do cast shadow of an object placed in their path. In case if there is any object, irregular object, they do cast the shadow of this object placed in their path. Number one, shadow. Okay, shadow is being projected there. And similarly, like the cathode rays, they also rotate a paddle wheel. Okay, in case you are putting a paddle wheel, this wheel will be rotated because of the high momentum of these things coming up with, and also have a heating effect also. Rotates paddle wheel and shows heating effect. High heating effect is being shown. Thus, these rays possess kinetic energy. And because the mass of the particles are present here, so there will be some mass associated with it. And the velocity, so momentum is there, and also a good amount of kinetic energy is there. And number three, these rays, when produced on zinc sulfide screen, okay, the zinc sulfide screen, that gives us the scintillating effect. The fluorescent colors are being produced. Fluorescent colors are being produced when these rays are being hit on the zinc sulfide screen. And the same thing again, this rays also get deflected because they also have a charge associated with them. As they do have a charge, if you put a negative terminal of the battery, they get deviated towards the negative terminal. These rays do have the tendency to get deviate towards the negative terminal, indicating that they are positive rays. And as I have bar magnet here having the south pole and the north pole, these rays get deviated towards the north pole, towards the south pole. Okay, they get deviated towards the south pole, indicating that this charge is of a positive charge. And these rays are also called as canal rays. Canal rays, okay, as they are, or anode rays, because they are definitely liberating out from the anode, also called as canal rays, since they pass through the canals of the cathode. Cathode, what we have taken cathode is a perforated cathode, and as they pass through this perforated cathode, they are also called as canal rays. Canal rays or anode rays. You have everything point wise in your textbooks, in your PACE textbooks. Please go through them, each and everything point wise, and do let me know if you don't understand any of them, right? So now moving on to the next ever discovery of your neutrons by Chadwick. Okay, Chadwick, Mr. Chadwick has given us the theory of neutrons. Neutrons by Chadwick. Okay, here is neutrons by Chadwick. Yes. Now, yeah, one more thing. I think we have missed on one point here. Come back, come back, come back. Yes. The charge by mass ratio, right? Charge by mass ratio for the protons. What would be the charge by mass ratio? Charge by mass ratio. Now, what is the charge? Charge is 1.6 into 10 to the power minus 19 coulombs. And what would be the mass? Is 1.67 into 10 to the power minus 27 kilograms. That will be your mass. So the charge by mass ratio of the proton is around 1.672 into 10 to the power minus 24, right? So this, one second, just, yeah. Minus 24 will be your grams there. Yes. So, and the charge by mass ratio is found to be 9.57 into 10 to the power 4 coulombs per grams. In case you want to put it in grams, this kilograms, you would convert it into grams, then it is 10 to the power minus 24 grams, because times 1000, it is 10 power minus 24 grams. Now, the charge by mass ratio of protons is 9.57 into 10 to the power 4. So you need to remember, or that is almost equal to 1.007 AMU, atomic mass unit. Atomic mass unit, this is what we take it as. One effective mass of proton, what we take it as 1 is derived from this 1 AMU. This is considered to be a 1 AMU, right? Now, so let's go now ahead on the discovery of neutrons by Mr. Chadwick. Okay, so the neutral charge particle, neutron, this is neutral charge, is given by James Chadwick. James Chadwick. Okay, by bombarding, how has he done this? He has bombarded boron or beryllium with alpha particles. Let us take beryllium. Beryllium comes at number 4 in the periodic table, having a mass of 9. This is how I write it. Having 4, having a mass of 9. He has bombarded with an alpha particle. Now, what is an alpha particle? Alpha particles are 2 protons plus 2 neutrons. Okay, each alpha particle consists of 2 protons and 2 neutrons, right? So this is what an alpha particle is. Now, alpha particle, I'm also writing the same thing, 2 protons and 2 neutrons. The proton number I'm writing in the bottom denominator, and numerator, and this, in the top of the portion, I am writing your mass numbers. Mass numbers is proton plus neutrons, 2 protons plus 2 neutrons. That is how it is 4. Now, let us see what is that he has observed. He has observed that there is a particle coming up with no proton number and having a unit mass. And this he named it as neutron. And then what is that left out? As you can see, protons 4 plus 2, my equation has to be balanced here. 4 plus 2 is 6. So he has seen a particle with 6 atomic number, which is nothing but our carbon, bhai sahab, right? So now this carbon is having the mass, is at having the atomic number of 6. And what would be the mass? As you can see, the left side mass should be equal to the right side mass. Left side mass is 9 plus 4, 13. So right side, already 1 neutron we have. So this has to be 12. Isn't it? 1 plus 2 is 13 on the right side. Left side, 9 plus 4 is 13. That is how you would write your equation there, right? So thereby, this is the part wherein the neutrons are being discovered, not invented, discovered by Chadwick, James Chadwick. He has bombarded the neutrons onto the beryllium atom or boron atom also, you can go, thereby liberating neutron here. This is how a neutron is represented with a mass 1 and no atomic number, right? Now, so I'm just briefing it now on this. So we have electron, we have proton, and neutrons. Okay, let us write the mass for each and everything. First, mass, very importantly, mass of an electron is 9.1 into 10 to the power minus 31 kilograms. Mass of a proton is 1.67 into 10 to the power minus 27 kilograms. And mass of a neutron also is the same, 1.67 into 10 to the power minus 27 kilogram. In case your question asked to you is in grams, convert it into grams, just multiply with 10 power 3, which becomes 10 power minus 24. I'm not writing it, you can write it down in your notebooks. All right, next, then we have your charge, right? Charge of an electron is negative 1.6 into 10 to the power minus 19 coulombs, and charge of a proton is positive 1.6 into 10 to the power minus 19 coulombs, and charge of a neutron charge is 0. No charge, right? And then we talk about their relative charges. Relative charge of an electron is -1, relative charge of the proton is +1, relative charge of the neutron is 0. That is how we consider them. All right, so this is about your discovery of these atomic, subatomic particles, protons, electrons, and neutrons. Now let us also discuss about the Niels Bohr's theory of an atom, how the radius is, everything about the velocities of the electrons moving around, energies in the orbits, all these things we are going to discuss now. All right. Now, here comes up the Bohr's atomic models, right? The Niels Bohr's atomic model. Niels Bohr's atomic model is been given by Niels Bohr in 1913, right? Very new model, definitely. Now, according to his theory, he said that this is the nucleus wherein protons and neutrons, right? Protons and neutrons are in the nucleus, and electrons revolve around the nucleus. Electrons revolve around the nucleus in particular shells, orbits, okay, called as energy shells or energy orbits, and they do not radiate energy. Rutherford has given us a similar theory, saying that electrons revolve around the orbits, around in orbits, radiating energy. But that point of radiating energy is very much wrong, because as they radiate energy, they should lose amount of charge and all, and they eventually should fall into the nucleus. But atom is very stable, so this never happens, right? So which means Niels Bohr has given us a theory stating that yes, electrons do revolve around the nucleus, but in energy shells. Each and every shell, each and every orbit has its own energy. which will never be created nor destroyed. It is all maintained the same, right? As long as the electron is in a given orbit, its energy does not change, no change in the energies. And the energy depends on the radius also, whichever is the radius of an atom, of an electron moving in that particular orbit. We need to talk about that radius there, right? And he has also stated something called as angular momentum of an electron. Angular momentum. Now, what do you mean by angular momentum? It is mvr is my angular momentum given by nh by 2 pi. nh by 2 pi. N indicates the number of the orbit. Is that the first orbit, second orbit, third orbit, everything? Okay. mvr, mass stands for the M stands for the mass. V stands for the velocity. This I'm writing. This is the mass. V stands for the velocity, and R stands for the radius. Okay, R stands for the radius. H is your Planck's constant. Planck's constant is given by a particular value. We have a proper value associated with the Planck's constant. H is written as 6.626 times 10 to the power minus 34 joules per second. Okay, so this is your Planck's constant value, and n stands for the number. N stands for the number of the orbit or positive integer. This is definitely, this is orbit number. Orbit number 2 pi, you already know, right? 2 times pi is 22 by 7. The same thing, right? And he also proposed that when an electron jumps from the higher energy state to the lower energy state, okay, when the electron jumps from higher energy state to the lower energy states, it emits the radiation because it has to come closer. It has to release a lot of energy. It emits the radiations in the form of photons or quantums. Quantum is a very important term here. Quantum or photons, the lowest amount of the particles, the least amount of the particles, which has got almost negligible mass. These things will not be obeying the Newton's laws of motion, right? So thereby we need to talk about quantum physics, quantum mechanics, quantum chemistry, right? So everything related to quantum is all about your so very tiniest particles, your protons, electrons, neutrons, photons, right? So all these things we are talking about now. Now, radiation occurred only when an electron made a transition from the higher energy state to the lower energy state. Okay, and the difference in between the energies of the two states is being radiated by these photons. And when this happens, okay, when this, change happens from the higher to lower, then definitely there is something called as electromagnetic spectrum that is being detected. Okay, and what is electromagnetic spectrum? The slightest variations in the amount of energies are seen as light of different colors. Okay, that is what is emission spectrum, what we call it as emission spectrum. Now, what is that electromagnetic spectrum that we have? You can remember it through a meme, okay, wherein I can say, read my instructions, read my instructions, visible under X-rays glasses cosmically. So this is a meme wherein read stands for radio waves. Radio waves. M stands for microwaves. I stands for infrared. V stands for visible spectrum. Visible spectrum is wherein you get all these colors, Vibgyor colors, VIBGYOR, all these Vibgyor colors in this range. U stands for UV rays, ultraviolet rays, and X stands for X-rays, obviously X-rays, and G stands for gamma rays. Okay, gamma rays, and C stands for cosmic rays. Okay, these are the waves, electromagnetic spectrum. This is called as an electromagnetic spectrum, to be remembered definitely in this order only. Please do not change the order. For this order to get remembered, this is how we go. Read my instructions. Visible under X-ray glasses cosmically. Okay, wherein radio waves, microwaves, infrared, visible, UV rays, X-rays, gamma rays, and cosmic rays. And remember one more thing, the leftmost part is got the highest wavelength, the highest lambda. So this point itself will talk about everything. Highest wavelength here, which implies least frequency. Highest wavelength will have definitely the least frequency, right? So because if I talk about the wavelength, see wavelength, this is how the wavelength is, crest to crest or trough to trough, not necessarily crest to crest. Any point on one wave to the corresponding point onto the other wave. That length is defined as your lambda wavelength. Now, as the wavelength is more, definitely number of waves passing per second will be less, which means highest frequency implies highest lambda, highest wavelength implies least frequency. Frequency is denoted by letter nu. Least frequency denoted by letter nu here, frequencies. Okay, so obviously as you move on to the right side, highest lambda to the left, so least lambda to the right, and least frequency to the left, so highest frequency to the right. So you can go accordingly. So because questions can be asked, you will be given about a couple of rays and you will be asked to arrange them in the increasing or decreasing order of their wavelengths or their frequencies. Thereby we can go accordingly to our meme. Read my instructions. Visible under X-rays, glasses, X-ray glasses cosmically. That is how we can go. So this is about your electromagnetic spectrum. And let us now go with the Bohr's model here. So Bohr's model, we have talked about the angular momentum, MVR, is NH by 2 pi. Okay, wherein H is the Planck's constant. This is the quantum theory has been given by Max Planck, right? So it is his value of H given as 6.625 into 10 to the power minus 34. There are a set of values here which you have to remember. And as I told, this is so very important for your JEE, not just JEE, for your MSET, JEE, Mains, Advanced. Okay, 2 questions from this chapter is for sure. All right, so be focused on this and then learn the concept well. Okay, just try to remember a few of the formulations which we are going to now discuss about here. Now coming up with your radius first. Okay, we have first right now written MVR. MVR is equal to NH by 2 pi. This is your part. And radius of the nth orbit, the second one, radius of the nth orbit is NH by 2 pi the square times, and denominator you have KME square and Z. Now what are these things? Here N stands for the number of the orbit. Okay, this is orbit number. H is your Planck's constant, which is 6.626 or 625 into 10 to the power minus 34. Then 2 pi value you already know. Pi is 22 by 7 that we can take up. Then K is your Coulomb constant, which is 1 by 4 pi epsilon naught. Epsilon, this is called as epsilon naught. This is K value, again a fixed value, which is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, this is 9 into 10 power 9. This is also a fixed value which you should observe. And the mass of the electron, we know already, mass of the electron is 9.1 into 10 to the power minus 31 kilograms. And Z stands out to be your atomic number. Okay, this stands out to be your atomic number. And N with the orbit. See, what is the variable part here? The variable part only is your nth orbit, whichever orbit I talk about, and Z, whichever element I am talking about. The rest all remains to be the constant, right? So if we just consider the N value and Z value, which means this is N square value, and Z out separately, then what is that we are going to get? When I substitute all these values here, I am going to get the value as 0.529 n square by Z, angstrom units. This is the units. Angstrom units is nothing but 10 to the power minus 10 meters. Angstrom units is into 10 to the power minus 10 meters, you would write. So radius is measured in meters. Angstrom units is 10 power minus 10 meters. Now you will remember this radius of the nth orbit for sure. And yes, don't forget to remember the formula, nh by 2 pi the whole square divided by kme square z. Okay, once you remember this, if you substitute all these values here, we are going to use this as 0.529, or I can just take it as 0.53 as well. N square by Z, N square by Z. This also is being considered based on the calculations, depending on the calculations, because we have a hell lot of calculations going up with this chapter. So always make sure you go with rounding it off a little bit so that it will be useful for you. It will be easy on your calculations. Yes, and hereby we have written number 2 as well. Number 1 is angular momentum, which is MVR equals to NH by 2 pi, and radius of the nth orbit is also given. And number 3, I'm talking about what will be the velocity of an electron moving in the nth orbit. Here the radius of the nth orbit, this is second one is radius of the nth orbit. So which is the radius of second orbit, or third orbit, fourth orbit? Okay, so that is the radius given there. For whichever atom you will talk about, Z is being given there. Just substitute the value of Z as your atomic number there. You would get your answer there. And what would be the velocity of an electron moving in this nth orbit? There is some velocity apart, associated with it. Velocity of an electron in the nth orbit is written as 2 pi k ZE square by NH. You don't need to remember this. What you should remember but is the value of it. When I substitute all these values except my Z and N, because these are the two things which are variable, rest all are same constants, then the answer which I'm going to get here is 2.16 into 10 to the power 6 Z by N, and the units is meters per second, because this is the velocity we are talking about. 2.16 times 10 to the power 6 Z by N. This should be remembered. This is the velocity of the nth orbit. So right now we are done with 3 of the formulations. You should remember 3 formulae. Number 1, MVR equals to NH by 2 pi. Then radius of the nth orbit and the velocity of the electron in the nth orbit. These 3 dabbe, 1, 2, 3, be fixed on it. Write it down separately in your pace books only. Otherwise, whichever notes you're talking about, you're writing all these things, please write it at the back end of the page, back end of your book, so that it will call you as you go with your revisions. It will call you, hey, I'm here. Yeah. So that is how you will go. Next, moving on. In case you're not able to write as fast as I'm writing, please pause it and then you write and then you release the pause. Again, play. So that is how we can go. Yes. Now, moving on to the next part, 1, 2, 3 formulations done. Let us also now talk about what is the energy, because we are talking about the energies and all, right? Energy of that particular shell. Okay, the next part we are talking about is the energy associated with this shell. Energy in the nth orbit. Energy is always a kinetic energy plus potential energy, right? This we already know, kinetic energy plus potential energy. And kinetic energy is half mv square plus potential energy here is given for this particular electrons as minus k ze square by rn. Although you don't need to remember these things, but the value is very important, which is minus 2.18 times 10 to the power minus 18 z square by n square. Please don't get confused by the z square, n square, z and n. So remember this. I will be repeating it again. Don't worry about that. nth orbit energy is kinetic energy plus potential energy, which is half mv square plus all this, which totally turns out to be this much joules per atom. Now, in case it is not the joules per atom, I want something in these many kilojoules per mole, kilojoules per mole. Now, what do I mean by mole? Mole is nothing but Avogadro number of particles together. So this much per atom, whatever we got it now here, times Avogadro number, which is Avogadro number we all know, which is 6.022 into 10 power 23 particular atoms. This together is going to give us the answer as minus 1312 z square by n square. Everywhere z square by n square only, because z square by n square is the variable part for whichever electron, whichever element we are talking about, in whichever orbit they are in, right? So these are a couple of things for energy. Also, we do have one more thing for the energy in electron volts. Energy also is given in electron volts per atom as minus 13.6 z square by n square. If you observe something here, z square by n square, common everywhere, check out. Okay, this is negative 13.6 z square by n square electron volt per atom. Okay, in case per mole you want, times Avogadro number you have to do. All right, so I'm not giving you so many things here to talk about. This is 1, 2 and 3. All of them is energy in the nth orbit. Energy of what? Obviously energy of the electron. Energy of the electron in the nth orbit is given by this. So we have written first earlier the radius, angular momentum, velocity of an electron, and the energies of these electrons revolving around in these particular orbits. Please be fixed on these things, very important. Okay, next set number 5. Set number 5. This is also very important. We have to talk something about wave number. Okay, wave number is, or first let me give you what is energy. Energy is equal to mc square. E equals to mc square. We all know this. Yeah, in any of the physics books, you will see this word, this formula first. E equals to mc square, where c stands for the velocity of light. Velocity of light, which is, this is speed of the light. I would write speed of light, which is 3 into 10 to the power 8 meters per second. This is your E equals to mc square, and E also is h nu. Nu stands for energy. And sorry, I'm so sorry. Nu stands for frequency. Nu stands for frequency. All this h nu stands for your energy. Okay, now we all know speed is equal to distance by time is what we have seen even from the from the 6th or 7th standards, I guess. Speed is equal to distance by time. That is what we have already known. Now, in the place of speed, I am taking it as velocity. Okay, velocity, which means if I have to talk about velocity, I am talking about the velocity of the light particle, which is a photon, which is quantum, right? So, which is equal to distance. Distance, I consider the distance in the quantum as wavelength, length of the wave, wavelength, times 1 by time. 1 by time is nothing but your frequency. This letter stands for frequency. I hope you already are accustomed to these terms, right? So C equals to h nu. This thing, I am using it here. This mc square is equal to h times nu. Nu times nu is what? C by lambda. So E is equal to h nu, E equals to hc by lambda, and wherein if I go on cancelling on these, mc is equal to h by lambda, lambda equals to h by mc. H by mc. Now, what is mc? M stands for the mass, c stands for the velocity, and mass into velocity is nothing but momentum. So, h by p, lambda equals to h by p is called as de Broglie's wavelength. De Broglie's wavelength. This is wavelength. De Broglie's wavelength has been derived here is lambda is equal to h by mc. M stands for mass, C stands for the speed of the light, which means nothing but the velocity. Mass times velocity is momentum. That's what I've written it as P. P stands for momentum. So lambda equals to h by P. This is de Broglie's wavelength. This is one other set number 5, set number 5. Right? So these sets, please do remember all these sets so as to do your numericals properly, perfectly. All right, let us go with one more set, the last and final set here, set 6. Okay, I want you to write all these things in your notebooks, bache, because yes, they are given in your pace textbooks, but in your handwriting, in your own style, if you write, they will start calling you, right? So during your exams, that will be more helpful. All right. Now, let's go with something called as wave number. Now, what is wave number? Wave number is how many number of waves are passing in 1 centimeter distance, 1 centimeter. See, number of waves passed per second is definitely your frequency, right? Frequency is nothing but number of waves passed per second. But what do you mean by wave number? Wave number is nothing but your number of waves passed during 1 centimeter length. That is your wave number. So wave number is denoted by nu bar is 1 by lambda, 1 centimeter to the lambda here. So 1 by lambda is given as your nu bar. And this is always equal to, there is a constant called as Rydberg's constant. Rydberg's constant into 1 by n initial square minus 1 by n final square. In case the electron is moving from one orbit to another orbit. So orbit 1 and orbit 2 are these initial and final n values associated with the number of the orbit, and RH stands for something called as Rydberg's constant. This is RYDBERG, Rydberg's constant. Now, Rydberg's constant value is 109677. Okay, 109677. This is the number which you would generally use, but not many of the calculations related to this you will get. So don't worry about those things. Just go with these things now. For now, these are all the formulations which you have to go through, because these are all what being asked. All right, so we are now going to stop this here. Please go through these all the theory ones. Then in the next class, we are going to discuss about the questions, about the numericals, about the theory questions, everything related to your PACE materials we are going to discuss from here on. All right, so please go through it completely, thoroughly, and reach out to me on any of the doubts. Bye-bye. See you and happy learning, all of you.